Hello to everyone, welcome to Focal Academy. See this problem here. For a linear system, the input function and output function is given here, and asking that how can you find transfer function? How can you find the transfer function? So first of all, recall what is transfer function. So transfer function was represented with h of s, that is the ratio of output by input in frequency domain, that is y of s by x of s. So this ratio is called as a transfer function. So just output was in frequency domain and input was in frequency domain, so their ratio is called as transfer function. So according to the problem, we need transfer function. So this is the standard definition for transfer function. So from this we are going to find the transfer function. Let's see here. But here given that the input and output was given in time domain. So now convert this into frequency domain as, how can we convert means by using Laplace transform. So with the help of Laplace transform, we can easily convert time domain to frequency domain. So let's first of all check x of t, that is e power minus t of t. So is it a standard function or it is a not standard function? So first of all, recall the all standard Laplace formulas. So by recalling that, we got one standard formula, that is Laplace transform of e power at u of t equal to 1 by s minus a. So from the standard formulas. So it is in this format. So by comparing that, we'll get a equal to minus 1. E power of at, here a is minus 1. So a equal to minus 1. So Laplace transform for this x of nothing but in frequency domain, it can be written as x of s, that is equal to 1 by s minus a. 1 by s minus a, minus or minus plus 1, so plus 1. So this is x of s. Now simply find y of s. So y of s nothing but Laplace transform of y of t. So Laplace transform of y of t nothing but y of s on LHS. On RHS, now I can find the Laplace transform for this. So first of all, recall, is there any standard formula from Laplace equations? So that is, so by recalling that, we have one standard formula, that is Laplace transform of e power at cos bt equal to s minus a upon s minus a whole square plus b square. So this is a standard formula. So it is in this form. So first of all, keep 10 outside, it is a constant value. So up to here, it is in this format. So by comparing that, we'll get a equal to minus 1 here. Next, b cos bt, b nothing but 4. Now substitute a value, b value in this, we'll get, so keep 10 as it is, that is 10 into, for this function Laplace means s minus a is minus 1 minus minus plus 1 upon s minus a means minus minus plus 1 whole square plus b square. So b is 4 square. Now consider this is equation 1 and this is equation 2. Now substitute x of s and y of s in this equation, we will get transfer function h of s. So that is, so h of s is equal to y of s by x of s. So y of s is, this is, that is 10 into s plus 1 upon s plus 1 whole square plus 4 square, nothing but 16. So upon x of s is 1 by s plus 1. So from algebra, we know that a by b upon c by d nothing but a by b into d by c. So it becomes 10 into s plus 1 upon s plus 1 whole square plus 16, that is a by b as it is, into d by c. So c by d becomes d by c as multiply. So into inverse of it, that is s plus 1 by 1. Now expand these two equations, means multiply numerator and expand this term, then we get h of s is equal to 10 into s plus 1 multiply. It becomes x plus 1 whole square. So upon, so s plus 1 whole square plus 16 into 1. Remember, it is same as this. Next, explain this by using a plus b whole square formula. It becomes 10 into s square plus 1 square plus 2s upon, expand this term also, becomes s square plus 1 square is 1 plus 2s plus 16. So it becomes 10 into s square plus 2s plus 1 upon, so s square plus 2s plus 16 plus 1, nothing but 17. So it is h of s. So this is the required transfer function. This is the required transfer function for the given problem. So and this is the process of simplification. And thanks for watching. Please subscribe, like, share. Thanks.